There's a giant blob beneath Africa, and it may be tearing the planet apart.
For most of human history, we believed the ground beneath our feet was solid, stable, and permanent. Mountains looked eternal. Continents seemed fixed. The earth felt like a finished world. But deep below the surface, far beneath Africa, something enormous may be rising. A giant mass of superheated material, a hidden force from the planet's interior. A structure so vast and so strange that scientists believe it may be helping rip part of the Earth apart.
And if they are right, then what is happening under Africa is not just a local geological story. It may be one of the biggest clues to how continents break, oceans are born, and how the deep interior of our planet still shapes the surface in ways we are only beginning to understand.
Because Africa is changing. Very slowly on human timescales, but on geological timescales, dramatically. A massive fracture system stretches across eastern Africa. Volcanoes rise where they should not. The land is being pulled apart. In some places, the crust is thinning. In others, the ground is lifting upward, and beneath it all may lie one of the most mysterious features inside the earth.
A giant blob. Not a blob in the simple sense, of course, not something floating like a bubble in water.
What scientists are really talking about is a huge region deep in Earth's mantle, where the material appears hotter, denser, and different from its surroundings. A colossal structure that may be connected to mantle plumes, volcanic activity, and the gradual splitting of a continent. And if this process continues long enough, East Africa may someday become its own separate landmass, with a new ocean forming between it and the rest of the continent. That sounds like science fiction, but it is geology.
To understand this, we have to begin with a truth that is easy to forget. The Earth is alive, not biologically, but physically. Its outer shell is broken into tectonic plates that move, collide, grind, dive, and separate.
The planet constantly recycles its crust. Oceans open and close. Supercontinents form and break apart. What looks permanent is only temporary.
Beneath the thin crust lies the mantle, a vast layer of hot rock that can flow over immense spans of time. And below that is the core, the metallic heart of the Earth. Heat from deep inside the planet drives slow convection in the mantle, and those motions help power plate tectonics at the surface.
Most of the time, we think about tectonics in terms of plate boundaries. Earthquakes in California, volcanoes in Japan, mountain building in the Himalayas. But Eastern Africa is different. This is one of the few places on Earth where a continent is actively being torn apart from within. The East African Rift System stretches thousands of miles from the Afar region in the northeast down through eastern Africa. It is a colossal scar in the making. In some places, the landscape is split by long valleys and steep escarpments. In others, lava fields and volcanoes reveal how much energy is trapped below. This is not just a crack on the surface. It is a deep tectonic process. The African plate itself appears to be dividing into smaller pieces, often called the Nubian plate and the Somali plate, with additional complexity involving microplates in between. That means the continent is under tension. It is being pulled apart.
But why here? Why is East Africa one of the most tectonically active continental regions on Earth?
Part of the answer may lie far below the crust, perhaps even near the boundary between the Earth's core and mantle, nearly 3,000 kilometers down.
Using seismic waves from earthquakes, scientists can image the deep Earth in a way somewhat similar to a medical scan. When seismic waves travel through different materials, they change speed. By measuring those changes, researchers can build maps of structures hidden far below the surface.
And those maps have revealed something astonishing. Deep beneath Africa lies an immense region where seismic waves behave differently than expected. This has been interpreted as part of a large anomalous structure in the lower mantle, one of the two giant deep mantle provinces often discussed by geophysicists, with the African one being especially intriguing.
These regions are sometimes described in simplified language as giant blobs. Scientifically, they are often linked to what are called large low-shear velocity provinces, or LLSVPs. That technical name comes from the way certain seismic waves slow down when passing through them.
But what exactly are they? That is where the mystery deepens.
Some researchers think these regions are hotter than the surrounding mantle. Others think they may also be chemically distinct, made of material with a different composition or history. Some models suggest they are ancient, possibly stable features that have existed for hundreds of millions of years, or even longer.
Others focus on how they may act as birthplaces for mantle plumes, giant upwellings of hot material that rise toward the surface. If that is true, then the blob beneath Africa may not be just sitting there. It may be feeding something.
Imagine a column of hotter mantle material slowly rising upward over vast spans of time. As it rises, it can weaken the lithosphere above it, the rigid outer shell made of crust and uppermost mantle. Heat can thin that shell. Upwelling can push it upward. Extension can begin. Faults form, volcanoes erupt, rifting accelerates.
In other words, deep mantle dynamics may help prepare a continent to break apart. This idea is especially important in East Africa because the region shows multiple signs of deep influence: the elevated topography, the broad doming of the land, the volcanism, the active rifting, the unusual heat flow. Put together, it suggests that something powerful is happening beneath the surface.
One of the most dramatic places to see this is the Afar Triangle, where three tectonic rifts meet: the Red Sea Rift, the Gulf of Aden Rift, and the East African Rift. This is a geological crossroads, a place where continental crust is being stretched so intensely that it resembles the early stages of ocean basin formation.
In some parts of Afar, the crust has become so thin and so fractured that magma can intrude directly into widening cracks. It is one of the closest modern analogs scientists have to the birth of a new ocean.
And that makes East Africa extraordinary, because we are not just seeing the aftermath of tectonic change. We are witnessing the process itself. Very slowly, yes, but unmistakably.
The landscapes of Ethiopia, Kenya, Tanzania, and beyond preserve the signatures of tension and uplift. Volcanoes like Erta Ale and Kilimanjaro remind us that the deep earth does not only build mountains by collision, sometimes it reshapes continents by tearing them open. And yet, despite the drama of the surface, the true engine may lie much deeper. The blob beneath Africa challenges a simple view of plate tectonics. It suggests that the surface does not only control the deep earth. The deep earth may also initiate major changes at the surface. That matters because continents do not split randomly. Something has to weaken them. Something has to focus the stress. Something has to provide the heat, buoyancy, or structural instability needed to turn solid crust into a future ocean boundary. This is where mantle plumes enter the story. A plume is like a slow-motion thermal upwelling, a rising mass of hotter-than-average mantle. When plume heads reach the base of a continent, they can cause uplift, flood volcanism, and widespread weakening. Some scientists believe plume activity played a major role in ancient continental breakups, including the breakup of supercontinents like Pangaea. Africa may be showing us a modern version of that process. Not identical, not simple, but related. And this is why the giant blob matters. Because if it helps generate plumes, and those plumes help trigger rifting, then the story of East Africa begins not at the surface, not even in the shallow mantle, but deep in the planet's interior. That is a staggering idea. It means the future shape of continents may depend partly on structures hidden thousands of kilometers below our feet.
Of course, geology moves at a pace that can be hard to grasp. No one is going to wake up tomorrow and find half of Africa gone. Continental breakup takes millions of years. Oceans do not appear overnight. Even dramatic earthquakes and volcanic eruptions are only brief moments in a much longer cycle.
But over enough time, the consequences become enormous. If rifting continues, East Africa could eventually detach from the rest of the continent. Seawater could invade the low areas. A narrow sea could widen into a young ocean. Coastlines would be redrawn. Ecosystems would shift. Entire regions would transform.
What looks today like a landlocked rift valley could become tomorrow's ocean basin. And Earth has done this before.
The Atlantic Ocean itself began as a rift. Long before it became a vast body of water separating continents, it started as tension, thinning, and breakup. The same basic planetary logic may now be unfolding in Africa. That does not mean scientists agree on every detail. They do not. Some debate how much of the rifting is driven by deep mantle upwelling versus forces acting within the plates themselves. Others argue over the exact nature of the African deep mantle province. Is it mostly thermal? Mostly chemical? A mixture of both? How stable is it? How directly does it connect to specific plumes? How much of East Africa's uplift can be explained by deep buoyancy? These are major scientific questions, and the answers are still evolving.
But even with uncertainty, the broader picture is clear. East Africa is one of the most important places on Earth for understanding how the deep interior of the planet interacts with the surface. It is a natural laboratory for continental breakup.
A window into mantle dynamics. A reminder that the world we live on is not a static shell, but part of a much deeper system of heat, motion, and transformation. And there is something profoundly humbling about that. Civilizations rise and fall on the crust. We draw borders, build cities, and imagine permanence. Yet below us, rock flows in darkness. Heat migrates upward. Ancient structures persist for eons. And sometimes, when the conditions are right, the deep earth reaches up and begins to remake the map.
So when people hear the phrase giant blob beneath Africa, it may sound sensational. But behind that phrase is a real scientific mystery. A deep mantle anomaly of enormous scale. A possible source of plumes. A hidden participant in the slow tearing of a continent.
And maybe, just maybe, one of the keys to understanding how Earth reinvents itself. Because our planet is not finished. It is still under construction. Still cracking, drifting, and reshaping. Still hiding vast forces beneath a surface that only seems calm.
And under Africa, one of those forces may already be at work, lifting, heating, weakening, and pulling a continent toward a future no human will ever fully witness, but one scientists can already see beginning. A future where the land breaks. A future where the sea arrives. A future born in the deep mantle, in darkness, under immense pressure, where a giant blob may be helping tear the planet apart.
That is what makes this story so compelling. It is not just about Africa. It is about how Earth works, how continents live and die, how oceans are born, and how the deepest parts of our planet may shape the destiny of the world above.
If you enjoyed this journey into the hidden machinery of Earth, subscribe to Infinite Science for more deep dives into the mysteries of the universe, our planet, and the forces that shape reality itself.
Because the more we learn, the more we realize something extraordinary. Even beneath our feet, the unknown is still enormous.